Okay, we want to determine the domain and range of the following. So h of x is equal to -1 over x minus 2 minus 2. So this is a reciprocal function. If we're looking at the domain, we can understand that the denominator can't equal 0, right? So in that sense, x minus 2 cannot equal 0, so therefore x cannot equal 2, right? So we can write down in our domain statement, x belongs to all real numbers, but x cannot equal 2, right? This restriction on the domain is the vertical asymptote when x is equal to 2. Now this question didn't ask us to construct a graph, but it's just kind of useful to understand like what the vertical asymptote is. Now in this case, the range, y belongs to all real numbers. Now the restriction on the range, this portion here, the -1 over x minus 2, we know that because it's a fraction, the only way a fraction can become 0 is if the numerator is equal to 0. In this case, this can never equal 0 because the numerator is a constant, -1, right? So because the numerator cannot equal 0, this fraction term won't ever equal 0, and then 0 minus 2 never happens. So y cannot equal -2, right? Because 0 minus 2 won't exist, right? The restriction on the y value, this is called your horizontal asymptote, right? The restriction on the range is the horizontal asymptote. In this case, y is equal to -2. So it'll be useful if you guys kind of construct a graph regarding this, right? Like if you do design a graph in terms of just graphing out the asymptotes, right? X is equal to 2, so the graph won't cross, whoops. The graph won't cross, let's say that this is the 2 mark. Okay, this is x is equal to 2, won't cross that point. And for y, the graph won't cross -2. Okay, so these would be the asymptote boundaries. In the next question, r of x is equal to the absolute value of x minus 3 plus 1, right? For the absolute value function, the domain of an absolute value function, I'm just going to change colors here. The domain for an absolute value function is going to be x belongs to all real numbers. There is no restriction on the domain, but there is a restriction on the range. And this actually kind of mimics the quadratic equation. It actually kind of mimics the ax minus h squared plus k, right? For absolute value functions, you can actually think about it as ax minus h plus k, and h and k are your vertexes. Your vertex, sorry, not vertexes, right? So h and k is your vertex, and in this case, the vertex itself is 3 and 1, okay? We'll look at this more when we look at transformations, but in this case, y belongs to all real numbers. Because the a value here is 1, right? It's going to be upwards, right? So it's going to be an upwards v shape. So we're going to say y is greater or equal to 1, okay?